Hello, my name is Badishya and I'm a member of Team Hades. I'm excited to present a robotics project to you in this video. Our project is under the guidance of our mentor Sai Krishna sir and falls under the domain of robotics. Our problem statement for the project is to design a system based on ROS to control a 6DOF mobile robotic arm, develop a system which recognizes gestures and controls the movement of the mobile robotic arm. This project involves designing a robotic system using the Robot Operating System ROS to control a mobile robotic arm with 6 degrees of freedom 6DOF. The system will also incorporate gesture recognition technology to enable users to control the movement of the robotic arm using hand gestures. To accomplish this, the system will use a combination of hardware and software components. The hardware components will include a mobile robotic arm with 6 degrees of freedom, a camera, and sensors to detect the arm's position and orientation. The software components will be built using ROS and will include modules for gesture recognition and controlling the movements of the robotic arm. For example, the user can make a fist to grasp an object and move the hand up and down to control the height of the robotic arm. The rover kit being used for this project is YF Robot 6WD chassis. One of the key features of the YF Robot 6WD chassis is a six-wheel design and is equipped with a series of shock absorbers that help to reduce vibrations and prevent damage to the internal components of the robot. The platform is designed to accommodate a range of different sensors and payloads, including cameras and other sensing technologies. Some of the notable components being used in the rover are Pixhawk. Pixhawk is an open source hardware and software autopilot. It is equipped with sensors such as accelerometers, gyroscopes, etc., which allow it to determine its position, altitude, orientation, and other important parameters. The Pixhawk autopilot can be programmed using the open source autopilot firmware, which features such as autonomous flight, waypoint navigation, object tracking, and more. Another important component is motor controller. A motor controller is an electronic device that is used to control the speed, torque, and direction of an electric motor. Motor controllers typically consist of a microcontroller, power electronics, and a control circuit. And Jetson Nano is another such component which is very important. The Jetson Nano is a small, powerful, and low cost computer board designed for developing and prototyping AI applications in robotics. It is created by NVIDIA. Its compact size and low power consumption make it ideal for use in embedded system, drones, and other robotic applications. In this way, the rover kit had been built, and to test out the rover, we mainly use two methods. One is through Mission Planner, a non-GPS way, and another is through using a GPS. Mission Planner is a powerful open source software application used for planning, testing, and executing autonomous missions for unmanned vehicles such as drones, rovers, and boats. One of the key features of Mission Planner is its ability to create and execute custom flight patterns, which can include predefined waypoints, altitude and speed settings, camera triggers, and more. After this, we ran the rover using a GPS. Running a rover using a GPS involves using satellite signals to determine the rover's location and navigate it to a specific destination. These signals provide the rover's location information, which can be used to control its movements. After this, we installed Ubuntu ROS Mavros in our Jetson Nano and designed some code to run the rover. Mavros is a middleware that enables communication between the autopilot running on the rover and the higher system running on the Jetson Nano. ROS, on the other hand, provides a flexible framework for developing a robot software by installing both Mavros and ROS. On the Jetson Nano, we can leverage the advantages of both the systems to control and monitor the rover's behavior. Our progress. Currently, our progress after completing all of this, we have assembled a robotic arm and are in the process of performing gestures with it. Now, we perform robotic arm simulation. Robotic arm simulation is an important step which allows engineers and designers to test the functionality, performance, and safety of the robotic arm before it is used in the real world. This robotic arm simulation can be done on either Gazebo RViz or Move It platforms. Thank you.